What's up, guys? I'm a researcher here at McMaster University. I'm here on a conservation effort in the Amazon rainforest in Brazil, South America. Our focus is to protect the spider monkey as its population is declining in the wild. We shoot them with a natural tranquilizer and transport them to our conservation reserve in order to try to increase their numbers in the wild. Oh my god, the monkey's falling from the tree right now. Where's the tranquilizer gun? Where should I shoot it? Above, below, or towards it?
Let's imagine we are trying to shoot a monkey in a tree. First, we need our rifle, which would be aimed at the monkey with an initial velocity of vi and a certain angle, theta. We could then break the velocity up into its components, the y component VIY and the x component VIX. The distance between the monkey and the rifle would be denoted by d and the height by h. Our measured values include the height at 66 inches or 1.68 meters, distance at 231 inches or 5.87 meters, angle at 16 degrees, and velocity at 320 feet per second or 97.5 meters per second. Now we can look at our velocity on y, which is vi sine theta, which is 97.5 sine 16, which gives us an answer of 26.87 meters per second. Now our Vx is vi cos theta, which is 97.5 cos 16, which gives us 93.72 meters per second. Now we can look at the vertical distance for the tranquilizer. Using our equation of motion, we have to substitute in velocity of y, and we're using acceleration due to gravity as the object is falling. After doing this, we can simplify our equation into 26.87 t minus 4.9 t squared. We can do the same thing for the monkey, as we have its initial height being h. When we substitute all of our values in, we can express our final answer as 1.68 minus 4.9 t squared. Now, because the distance of the tranquilizer in the vertical component and the distance of the monkey in the vertical component should be equal, as they should be colliding at the same instant of time, we can equate these two equations together and solve for the time it takes for them to collide. In doing so, we get 0.0625 seconds. Now, we can substitute this time into our original distance for tranquilizer equation to see where the tranquilizer would be at that instant in time. We can see after substituting it in, the distance for the tranquilizer will be 1.66 meters. Now we can do the same thing for the distance of the monkey. When substituting the time into the distance for monkey equation, we can see that the monkey's position at that particular time would be at the same spot at 1.66 meters. Now we need to see how far the bullet will travel. Using our range formula, range is equal to VIX times t, we can see that the horizontal distance a bullet will cover is 5.86 meters, which is very close to our original of 5.87. This means that we have to aim the rifle at the monkey. This is a tape measure showing our horizontal distance, which is 231 inches. We then use the tape measure to measure the vertical distance that the object was going to fall, and we set this to be 66 inches. Using the Bosch angle finder, we can see the angle that we placed the gun was 16 degrees. Using an old transformer, we created an electromagnet on a switch, and as demonstrated, when we turn off the switch, the can will fall. As you can see, the bullet made contact with the can, and here we can see our bullet entry and bullet exit, and it looks like it fell around 2 centimeters, which is correct based on our calculation. This means that we have to aim the rifle at the monkey in order to make contact and essentially tranquilize the monkey.